So this is chapter 10, section 2, number 45. We are trying to find the Taylor series for ln of 1 minus 3x. But instead of finding it piece by piece, we are going to use a different Taylor series, manipulate it to get there. Now, this is a sum of an infinite geometric series starting at 1 with a common ratio of x. And so this infinite series is equal to this function. But if I have this and I want to get that, how do I get there? You have to see that x has been replaced with 3x. So I'm going to call this, I don't know, h of x. And I'm going to say, I don't know, j of x is 3x. So I'm going to say this is actually h of j of x. It's a composition. I'm sticking j inside of h. And we learned to find the series for that, all you do is replace all the x's with your function you're putting inside. So now this function, if I substitute x with 3x, what's the Taylor series for that? I replace all the x's here with 3x. So let me do this also. Let me show you the summation notation of that. It's x to the k is 0 to infinity. And you need to be comfortable with both the summation notation and this notation. And oftentimes they have you write it with the general term, x to the k plus dot, dot, dot. So all those different forms you need to be very comfortable with. So don't avoid one. If you don't understand one, you need to make sure that you are comfortable with all of those. Okay, so I'm going to replace all the x's with 3x. 1 plus 3x plus 3x squared plus 3x cubed plus dot, dot, dot equals, I'm not going to put the general term because I'm out of room, k equals 0 to infinity of 3x to the k power. All right, let's simplify this. So now we have this function, 1 over 1 minus 3x equals 1 plus 3x plus 9x squared plus 27x cubed plus dot, 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 which is 3 to the k, x to the k. Okay. All right, we're almost there. Here is the tricky part. You're going to have to say to yourself, how do I go from this to this? And that's where integration comes into play. You realize if I integrate that, I'm going to get ln of that bottom, kinda. But I need to do some u subbing and stuff like that, right? So let's do this. We're going to integrate both sides with respect to x. Because I learned I'm allowed to integrate both sides of an equation. When I have a Taylor polynomial, it actually works. So I claim u is 1 minus 3x. du will be negative 3 dx, right? Do I have negative 3 dx? Now I do. So I have negative 1/3 integral. The top is du, the bottom is u. And that'll be negative 1/3 ln absolute u, which is negative 1/3 ln of 1 minus 3x. And isn't that what we're trying to find? Kinda? Yeah, we're trying to find that. That one we'll have to deal with. So how do we do that? Well, we learned if you want to integrate a function, the Taylor series will be the integral of that Taylor series. So The antiderivative of 1 is x. The antiderivative of that is 3x squared over 2, and we just keep going. And there'll be 9x cubed over 3, 27x to the 4th over 4, dot, 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 right? To do this, this gets crazier. Okay. So k is going to be a constant. So that's going to be a constant, right? Well, actually, yeah, liar, liar, pants on fire. Liar, liar, pants on fire. This k, actually, my brain is not working right now. I got the wrong, this should be dk on this last one. I apologize. I was getting confused. Because term by term, k is a constant, x is your variable. Okay, as you go term by term. So if you plug in 1, that'll be 1, that'll be 1. If you plug in 2, that'll be 2, that'll be 2, right? So x is your variable. So you're going to get 3 to the k, x to the k plus 1 over k plus 1. Are we all good with that? Okay, so it takes a while to kind of absorb that. So this will be x plus 3x squared over 2 plus 3x cubed plus 27x to the 4th over 4, which is this. Now, I want this alone, so I have to multiply both sides by -3. So ln 1 minus 3x equals -3x minus, and it's going to be 9x squared because I'm multiplying everything by 3, minus 9, wow, 9x cubed, and then minus 81x to the 4th over 4 plus dot, dot, dot. And in this case, I'm multiplying by 3. So -3, it's going to be -3 to the k plus 1 because I had k of them before. I'm multiplying by another 3, so I'm going to have an extra 1. X to the k plus 1 over k plus 1. And that's my story, and I'm sticking to it.